Good evening, children.
Good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening. Is my voice loud and clear, children?
Yes, ma'am.
Yes, ma'am.
Okay. All right, let's look at this question from arithmetic progressions. The sum of n terms of two APs are in the ratio 5n plus 4 is to 9n plus 6. So how do we express this? Two different APs. So their first terms are different. Their common differences are different. But in both the cases, it is the sum to the first n terms. In both the cases, it is the sum of the first 10 terms or the first 20 terms, first 30 terms. So n is the same in both the cases. See, there are three things that determine an AP. The value of A, N, and D. A, N, and D. A and D are different. N is the same. These are the three unknowns. When we take up an arithmetic progression, these are the unknowns. A, N, and D. A, N, and D. So let this be for the first AP. For the first AP, and let these letters represent the first term, the common difference, and the n terms of the second AP. There are two different APs, so we'll represent their first terms like this. Again, there are two different APs, so let these be their common differences. But in both the cases, it is a sum to the first n term, so n is the same in both. So let me say Sn by Sn. Again, we are differentiating. This is small letter s, this is capital letter S, is equal to 5n plus 4 by 9n plus 6. The sum of n terms of two APs are in the ratio given there. Find the ratio of their 18th terms. Find the ratio of their 18th terms. So we need to find this ratio. We need to find this ratio. The ratio of their 18th terms. We need to find the ratio of their 18th terms. So we need to find this. Okay, so to find this, we need to work with the given information. To find this, we need to work with the given information. So what is this? Do we understand the first step, children? Ratio, the ratio is given to us. Ratio, so it's like this. Sn by Sn. Small letter Sn, sum to n terms. By capital letter Sn. The ratio, so 1 divided by the other. Ratio, so 1 divided by the other. The sum of n terms, not the terms, the sum of n terms of two APs are in the ratio 5n plus 4 by 9n plus 6. We need to find the ratio of their 18th terms. All right, let's proceed. So see here, n by 2. Let me write again. Please write along with me. Please write along with me. Given Children, please write along with me. Please write, is it over? Tell me once it's over. Let me know once you finish writing, children.
Completed.
Yeah. Maybe if we write given and to find after this, it will make more sense. If we write this given, you know, this given, if we write this given and to find, so we'll do one thing, we'll write this first. We'll write this the two let statements first, and then we'll write given and to find, then it'll make more sense because, you know, we have described what A and D are, SN and all that, all those are. I think that will make more sense. You can just put an arrow. So we'll write this first, let A and D represent the first term and common difference. Again, let A and D represent all that, and then given and to find. Am I clear? Please say yes or no.
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Please write the let statements first, and then write given and to find. If you've already written, just put an arrow mark. See, all that is not a mistake in mathematics. It's okay. It's still fine, but it'll be better if you write given and to find after the let statements. Okay. I need to clear the slide.
Yes, ma'am.
Yeah. See, I'm saying three letters are A, N, and D. A, D are different because they're two different APs, but N is the same in both because some of the first N terms of two APs. So it's not small n and capital N. N is N for both. Okay. So we'll work with given. Okay. So what is that we are given? We are given that this one is 5n plus 4. So we are going to work with this information given. We need to work with this information given. So how do you expand on Sn? N by 2 of 2a plus n minus 1 into d. Be careful when you use A's and the letters A and D. Be careful when you use the letters A and D. So n by 2 of 2a plus n minus 1 into d for the numerator, and for the denominator, n by 2, the same small letter n, but 2a like this plus small letter n minus 1 into capital D, it's a second AP, is equal to 5n plus 4 by 9n plus 6. Please write down. We are expanding on Sn in the numerator and denominator. Finished? N by 2 gets cancelled. N by 2 in the numerator and denominator gets cancelled. Now in the rough column, do this in the rough column. Okay. How to proceed? I'll tell you how to proceed. Do this in the rough column. What should you find? You should find A18. You need to find this ratio. That means what should you get? You must get A plus 17D by A plus 17D. You must get this. Because A plus 17D is the 18th term. This is what you should get. But here we have 2a. We don't have a. We have 2a. So let's just multiply this by 2 and check. Children, we need to find this ratio. We need to find this ratio. OK. In other words, we need to find a plus 17d by a plus 17d. This one. But out here we have 2a. We don't have a. We have 2a in the numerator and 2a in the denominator. We don't have a. So what we'll do, this is rough work. This is rough work. This is just going to help us to proceed with these steps. OK, so now how do you, we'll multiply the numerator and denominator by 2. So what will that give us? 2a plus 34d by 2a plus 34d. This is what we have. So if you have to get a plus 17d by a plus 17d. Or you can also get 2a plus 34d, because on taking 2 common, you can still get a plus 17d. Just multiply the numerator and denominator by 2. You get 2a plus 34d by 2a plus 34d. You can get this also, because on taking 2 common, you will still get a plus 17d in the numerator and a plus 17d in the denominator. OK, so now what is the coefficient of d in the numerator and denominator? What is the coefficient of d? 34. Now compare this and this. Compare this and this. Compare this one and this one here. OK, see, we have an a term 2a and we have a d term n minus 1 into d. Here also we have an a term and a d term n minus 1 into d. 2a. Here also we have 2a. OK. Here we have the coefficient of d as n minus 1. Here we have the coefficient of d as 34 in both the numerator and denominator. So that means we'll equate the coefficients now. N minus 1 should be equal to 34. See here, I'm saying 2a in the numerator and denominator. Here also we have 2a in the numerator and denominator. The coefficient of d is n minus 1. Here the coefficient of d is 34. So n minus 1 is equal to 34. So we get n is equal to 35. So we need to proceed by taking, let n be equal to 35. We need to proceed. Now this is just a rough work. You don't have to present this as a part of the main answer. But you can show this in the rough column. Don't write this and erase it. Don't work this in a pencil and erase it. Let your teacher see what you've done. OK. But this need not be a part of the main working. That's what I'm trying to say. So this is your computation on n. N is equal to 35. So let n be equal to 35. So let me write it again for you. I'm just going to write the whole thing again for you. Sn, see here, Sn by Sn is equal to 5n plus 4 by 9n plus 6. N by 2 of 2a plus n minus 1 into d divided by n by 2 of 2a plus n minus 1 into d is equal to 5n plus 4 divided by 9n plus 6. N by 2 gets cancelled. Rough work. We need to find A18 by A18. This is nothing but a plus 17d divided by a plus 17d. Multiplying the numerator and denominator by 2, we get 2a plus 34d by 2a plus 34d. On comparing this one with what we have here and on equating the coefficients of d, we get n minus 1 is equal to 34. N is equal to 35. So we proceed by taking n as 35. Let n be equal to 35. So 2a plus, we're just giving a value for n. If you give this value for n, you can find the ratio of their 18th terms. Now it's not that why n should take only 35, why not some other number? You can give some other number. See, now here we need to find the ratio of their 18th terms. To find the ratio of their 18th terms, you have to take n as 35. OK. So n minus 1, 35 minus 1. into D minus 1 children. This is divided by 2 capital A plus 35. N is 35 minus 1 into D is equal to everywhere N is 35. Everywhere N is 35 plus 4 by N 9 into 35 plus 6. Now 2A plus 34D. See, we got it by 2 capital A plus 34 capital D is equal to 35 5s are 35, 70, 140, 175, 179. Please check on my calculation. I'm not sure about that. 350 minus 35 is 315 plus 6, 321. Yeah, please tell me if I'm right. Only then I can proceed. 5 into 35 plus 4 and 9 into 35 plus 6. Tell me if I'm right.
Yes, ma'am.
Okay, thank you.
Yes, ma'am.
All right, thank you. All right, so now take out 2 common in the numerator and denominator. So A plus 17D divided by 2A plus 17D, capital A, capital D, is equal to 179 by 321. 2 gets cancelled. And we know that A plus 17D can be written as A plus 18 minus 1. You can directly write A18. I'm just showing you this. You can directly write A18. Or you can write 17 as 18 minus 1 into D divided by capital A plus 18 minus 1. 17 can be written as 18 minus 1 into D is equal to 179 by 321. So A plus 18 minus 1 into D, A plus N minus 1 into D is the nth term. So A plus 18 minus 1 into D is the 18th term. A18 divided by A18 is equal to 179 by 321. So this is their ratio. This is the ratio of their 18th terms. 179 is to 321 is the ratio of their 18th terms. Is right. This is your rough work.
Completed, ma'am.
Okay.
Completed.
Yeah. Is it understood, children? So
Yes.
the value of, yeah, good. So the value of n depends on what ratio you have to find. So if you have to find the ratio of the 25th term, the value of n will be different. You will have to work and find the value of n in the same way as we have done in the rough column. So here there's a general one. This is given the ratio, finding the ratio, given the ratio of the sum to n terms of two different APs, given the ratio of the sum to n terms of two different APs, we had to find the ratio of their 18th term. 18th terms. Should be terms, not term. Okay. I repeat, what is given to us? The ratio of the sum to n terms of two different APs is given to us. And we have to find, or we have to find the ratio of their 18th terms. The term is mentioned here, 18th term. This is a question. We are given the same info. The ratio of the sum to n terms of two APs is given to you, but we have to find the ratio of their mth terms. So like the 18th terms, in the earlier one, like the 18th terms, here we have to find the ratio of their mth terms. Very close related the questions. So similar working. Exactly. Procedure is the same. Just that you'll be substituting different values. This. Please take the question, children. Okay. So I think you will write the two let statements as we saw in the earlier one. Let the two let statements, children. Please write the same thing. You write this and then write given. What is given to us? We are given Sn by Sn. The ratio is 7n plus 1 by 4n plus 27. And we need to find AM by AM. We need to find AM by AM. We need to find the ratio of the mth terms. Mth terms, AM by AM. Please acknowledge if you finished writing.
Completed, ma'am.
Okay.
Completed.
Okay. Okay. Am I erasing the slide? The contents of the slide, children? Okay. So now we'll work with what is given to us. What are we given? We are given this. We are given this one. This is what is given to us. Using this, we should find the ratio. So let's work on this Sn, meaning n by 2 of 2a plus n minus 1 into d divided by n by 2. N is the same of 2 capital A plus n minus 1 into capital D is equal to 7n plus 1 by 4n plus 27. N by 2 in the numerator and denominator gets cancelled. Now this is what we have. We have 2a plus n minus 1 into d. But what is it we need to find? This is a rough work. This is a rough work. What is it we need to find? We need to find AM by AM. That means we need to find A plus M minus 1 into D by A plus M minus 1 into D. Oh, capital D, capital D. But here we have what? We have 2a. So let's multiply the numerator and denominator by 2. So that will give us 2a plus 2 into M minus 1 into D divided by 2a plus 2 into M minus 1 into D. I think the place is not sufficient, so let me work it here. Let me continue here. So 2a plus 2m minus 2 into d by 2a plus 2m minus 2 into d. So on comparing the coefficients of d, we get n minus 1 is equal to 2m minus 2. Let me tell you again. You know that an is equal to a plus n minus 1 into d. You know this. You know that an is a plus n minus 1 into d. So similarly, am means am. Am means a plus m minus 1 into d. This is what we have to find, am by am. Don't go ahead of me, children. When I'm repeating something, please come back there. Otherwise, it only confuse you. You may not understand clearly. Follow me. AM by AM. AM is small a plus m minus 1 into small d. This AM, capital AM is equal to capital A plus m minus 1 into capital D. Okay, but since we have 2a here, we'll multiply the numerator and denominator by 2. So that gives us 2a plus 2. See, there are two terms. There is one a term plus there is one d term. There are only two terms. There is one a term here and the separator is plus and the d term. In the denominator also, we have an a term a plus m minus 1 into d. That's the second term. There are only two terms. Multiply the numerator and denominator by 2. So you get 2a plus. The second term, see, I've multiplied the second term by 2 here. In the denominator, 2a plus, I've multiplied the second term by 2. See, you're multiplying everything in the numerator and everything in the denominator. You're multiplying the numerator and denominator by 2. So this is how it looks like. I'm not doing this for my convenience. When you multiply the numerator and denominator by 2, this is how it looks like. Every term in the numerator and denominator is multiplied by 2. This is how it looks like. So 2a plus will not multiply the d because we want the d term. We want the coefficient of d. We don't want to multiply d with the terms outside. So we're just doing this. 2 into m is 2m. 2 into minus 1 is minus 2. In the denominator also, 2 into m, 2m. 2 into minus 1 is minus 2. We'll just multiply 2 with the terms inside the bracket. D will have it as it is. Now compare the coefficients of D in the rough column and the main working. The coefficient of D in both the numerator and denominator is 2m minus 2. Here the coefficient of D in the numerator and the denominator. The coefficient of D in the numerator and the denominator is n minus 1. We are equating that. We're equating that to get the value of n. To get the value of n, because we need to remove n and introduce m. We need to remove n and introduce m. So we are finding an equivalent expression. Equate the coefficients. N minus 1 is the coefficient of D. Here 2m minus 2 is the coefficient of D. In the new denominator also, n minus 1 is the coefficient of D. See here, 2m minus 2 is the coefficient of D. So whether you're comparing the numerator, the d's in the numerator or denominator, you will get the same thing. So on working this, n is equal to 2m minus 2 plus 1. So n is equal to 2m minus 1. So now we proceed this with let n equal to 2m minus 1. You're going to remove n and introduce m like this. And that way you will be able to find the ratio of their mth terms. Please write down so far, children. Is it over, children?
Yes, ma'am. Yes, ma'am.
All right. I need to clear the slide also. Hello children. So 2a plus n is 2m minus 1. And that minus 1 which is already there into d by 2a plus, instead of n we are going to use 2m minus 1. Minus 1 which is already there. n is 2m minus 1 minus 1 into d is equal to 7n. See, I forgot. Wherever there is n children. So 2m minus 1 plus 1 by wherever there is n. Here also there is n. So 2m minus 1 plus 27. That's it. You're done. Now, wherever you find n, replace that with the expression 2m minus 1. So 2a plus 2m minus 2 into d divided by 2a plus 2m minus 2 into d is equal to 14m minus 7 plus 1 divided by 8m minus 4 plus 27. Yeah, I'm right. So 2a plus 2 common m minus 1 into d divided by 2a plus 2 common m minus 1 into d is equal to 14m minus 6 divided by 8m plus 23. So here 2 is common. So you get a plus m minus 1 into d divided by 2 is common. A plus m minus 1 into d. 2 is common. A plus m minus 1 into d. 2 common again. A plus m minus 1 into d. There are only 2 terms. There is one a term and one d term. Both the terms have 2 in common. So bring it out. Is equal to 14m minus 6 divided by 8m plus 23. So 2 gets cancelled in the numerator and denominator. A plus m minus 1 into d is nothing but am divided by, again, capital A plus m minus 1 into capital D is am. Is equal to is equal to 14m minus 6 divided by 8m plus 23. So this is the required ratio. See, because it is given their mth terms, you cannot get a numerical figure. You cannot get a ratio like you got in the earlier one. You will get it in terms of m. So this is a general one. You can find the, see, supposing you want to find the ratio of their 20th terms. Everywhere in place of m use 20, you will get the ratio of the 20th. The last one was specific. Ratio of their 18th terms alone. Last one was specific. Ratio of their 18th terms is 179 by 321. This is general. You can now, using this general expression, you can find the ratio of their any terms. So if you want to find if you want to find the ratio of their 100th terms, if you want to find the ratio for these two APs, if you want to find the ratio of their 100th terms, A100 by A100 is equal to 14 into 100 minus 6 by 8 into 100 plus 23. If you want to find the ratio of their 50th terms, A50 by A50 is equal to 14 into 50 minus 6 by 8 into 50 plus 23. So now this is a general one. You can find the ratio of any terms meaning it should be the same term in both the APs. So if the 50th term in the first AP, 50th term in the second AP. So you can find the ratios using this the general expression. So given the ratio of the sum to n terms, we have found the ratio of their sum to, the ratio of their mth terms. Finished writing, children?
Completed, ma'am.
All right. Yeah, try these questions as homework, children. You've done them in the class earlier. I won't give you everything 1 minute. I'll just give you a few sums. Yeah, try this. Find X. Take a screenshot. Yeah, take a screenshot of this one. Second question, this one, meaning the 12th question, which is the second question for homework. This is not in your syllabus this year. You can try this. Take a picture. We'll discuss these sums in the class tomorrow. Four. That's all. 4 questions and all. This one. Okay, this one also 5 children. 5. That's it. Done. Take a picture of all the questions, all the 5 questions. Should I show you again?
Yes, ma'am.
Can you show again?
Oh. See, I'll come from behind. Okay, 1 minute. This is one. This is 2. This is 3. This is 4. And this is 5.
Took, ma'am.
Good. I think we finished this, right? How many silver coins? Yes, we finished this. What about this ice cream, some children? Is this over? Did we discuss this one? Please look at your notebook and tell me, children. Oh, there are 16 of you. Then why no response? Class, use the emoji. Raise your hand. Where are you, Harshita, Nishita, Priya? Okay, Bal Harish. Okay. Nishita and Priya, are we there? Want to drink water, is it? Nishita and Priya, no response. Okay. So we have Balarish, Harshita, Priyadarshini, Hariharan, Shreya, Sudarshan, Muthuvel, Nivedita, Srinivasan, Sabarigrish, Tirunesh, Arnav, Lakshita, and Shivani. Good children. All right. Hi, Priya.
I'm sorry, ma'am.
Okay. Children, please tell me, have we discussed this one or not? Oh
Yes, ma'am.
Okay.
Yes, ma'am.
Shreya and who's the other one?
Priyadarshini, ma'am.
What did you say? Priyadarshini. Okay. So this is over. Then we have to do this one. A well of diameter 3 meters. So visualize, okay, as we read, visualize a well in the villages, you know, which has a wall around it for protection. That wall is called the embankment here. The wall here is called the embankment. Okay. So mostly we see circular wells. The mouth of the well is circular. Sometimes the mouth of the well is also in the shape of a square or a rectangle. Wells can be cuboidal or cylindrical? Wells can be cuboidal. That means they can have a rectangular mouth, rectangular or a square mouth. See, I'm pausing so that you visualize. In temples, I think it's common to find wells with a square or a rectangular mouth. In houses, we mostly see wells with a circular mouth. Okay, so wells can be cylindrical or cuboidal. Cylindrical with a circular mouth or cuboidal with a rectangular or a square mouth. Now, the mouth of the well is on the surface of the ground. The mouth of the well is on the surface of the ground. So, obviously, for the sake of protection, there is a wall built. There is a wall built around the mouth of the well. A wall is built around the mouth of the well. So if the well has a circular mouth, the wall will also be circular. The wall will be built around the mouth of the well. That also will be circular, but it will have some height. So that wall is a cylindrical shell. That wall, if the well has a cylindrical, if the well is cylindrical, it has a circular mouth. If the well is cylindrical, it will have a circular mouth. Then the wall will be thick. The wall that is constructed around the mouth will be thick. And the wall also will be circular. But the wall has height, no. So it's not a plane figure, it's not a circle. The wall has a height. So the wall will be in the shape of a cylindrical shell. You have to visualize that. The wall will be in the shape of a cylindrical shell. Like how a sellotape roll looks, the wall will look like that. So in the middle is the well. The sellotape, that ring of sellotape, the wall will look like that, not so small. So just magnify the sellotape roll. The sellotape roll, just imagine it's big, it's very big. That's how the wall will look like. Okay. If it's a rectangle, if it's a cuboidal well, it'll be a cuboidal shell. The embankment that will be built around the mouth of the well will be a cuboidal shell or a square. In both the cases, it will be a cuboidal shell, whether it's a square or a rectangle. Now, coming to this case, here, a well of diameter 3 meters. So it's a circular mouth. The mouth is circular. A well of diameter means something of a circle. Okay. A well of diameter 3 meters is dug 14 meters deep. So the well diameter is 3 meters. So the radius is 3 by 2 meters. Is dug 14 meters deep. All right. The earth taken out of it has been spread evenly. So the earth which is removed, from the well, the earth which is removed. See, when you dig the well, when you dig the well, you're removing the earth. Only then it becomes a well. You're removing the earth. You remove the earth, and that earth which is removed, all the earth that is removed, is used to construct the wall around the well. All the earth that is removed in the process of making the well is used to build the wall or the embankment around the circular mouth of the well. That means the volume of the well, the volume of the earth that is dug out from the well is equal to the volume of the earth in the embankment. That's all. Finished. If you can write this equation in words, you will get the correct answer. Of course, you'll have to substitute carefully. We'll see all that. The volume of the earth that is removed from the well. So what is the volume of the earth that is removed from the well? It's the volume of the well, volume of the cylinder is equal to the volume of the earth that is in the embankment. All that earth which is removed from the well is now in the embankment. Nothing is wasted. All the earth from the well is now in the embankment. So the volume of the earth removed is equal to the volume of the earth removed is equal to the volume of the earth in the embankment. Okay, so we've written about the well. Let's write about the embankment. You don't have to write this, children. I'll show you the answer slide. Embankment. Okay. The embankment is a cylindrical shell. It's a cylindrical shell. So it will have small r, capital R, and H. Let's call this capital H or H1. We'll call this small h. The inner radius will be equal to the radius of the well because the embankment is built closely around the mouth of the well. So the inner radius of the embankment will be equal to the radius of the well. The inner radius of the embankment will be equal to the radius of the well, 3/2 meters. It's given that the width of the embankment, the width or the thickness of the embankment is 4 meters. The width or the thickness of the embankment is 4 meters. So capital R is small r plus W. So 4 plus 1.5, which is 5.5. 4 plus 0.5. Let me see the next slide. I don't know what I've written. 1.5, right? Sorry. 4 plus 1.5. So 5.5 or 5.5. Okay, 4 plus 1.5. That is 5.5 meters. Find the height of the embankment. We need to find the height of the wall. We need to find the height of the wall. Of course, one value should be missing, no? For the well, you know the radius and height. For the embankment also, if you know the inner radius, outer radius and the height, then what is that we have to find? Nothing. So one value should be missing, and that is the height of the embankment. So we have the equation with us, volume of the well. Volume of the well meaning volume of the earth. Volume of the earth removed from the well. Removed from the well. Where is all this earth which is removed from the well? It's equal to the volume of the earth in the embankment. Is equal to volume of the earth in the embankment. Earth in the embankment. This is the equation. So what is the volume of the earth removed from the well? Pi r square h. Pi r square h. Because for the well we use r and h like this. Is equal to embankment is a cylindrical shell. So pi r square minus r square into h. Pi capital R square minus small r square. See, we have not used R1 here because the radius of the well is equal to the inner radius of the embankment. So capital R square minus small r square into h. So pi gets cancelled on both the sides. Pi gets cancelled. Substitute the values. So this one is 3/2 or 1.5. And this one is 14. This one is 5.5. This one is 1.5 or 3/2. This is what we'll have to find h. Yes, children, please write the answer. So you can write volume of the well or the volume of the earth removed from the well, all the same. Volume of earth in the embankment. Therefore, the height of the embankment. Embankment is 1.125 meters. Please ask me what you don't understand, children. The embankment will be built closely around the mouth of the well. So the inner radius of the embankment will be equal to the radius of the well. The outer radius of the embankment will be equal to the inner radius plus the thickness of the wall, which is given to us in the question. Height of the embankment is what we have to find. All the values are given directly. So you should just write the equation in words, what you understand after reading the question. And then use the formula, substitute the values and work. Is this over, children? Completed writing this?
1 minute.
Okay.
Completed, ma'am.
All right.
Ma'am,
Yeah. Yes, Arnav.
that H1 is equal to 1.5 into 1.5 into 14 divided by 7 into 4 should come, no ma'am, because 5.5 minus 1.5 is 4.
Here, no denominator. Let me just check. Oh, yeah, that's a mistake there. Yeah, yeah. 5.5 minus 1.5 is 4. And 5.5 plus 1.57. Yeah, yeah, yeah. Class, what is this? You're blindly copied. Yes, thank you, Arnav. You're right. Finish, children.
Yes, ma'am.
Okay. Now see here what they do with the earth that is removed from, the well. In the question which we just finished, the earth which was removed from making the well was used to construct the embankment around the well. Now here, what do they do with it? A 20-meter deep well with diameter 7 meter is dug. So for the well that is dug, you know the radius, you know the depth. It's a cylinder. The well is just a cylinder. Well is a cylinder. Okay, it's like a deep drum. The well, how does it look for you? It looks like a deep cylindrical drum. A very deep cylindrical drum. It looks like that. How does it look like when you peep into a drum? So like that. It's a very deep cylindrical drum. So you know the radius and height for the well. And the earth from digging is evenly spread out to form a platform. This platform is not built around the well. Somewhere they're building the platform. Okay. It's spread out to form a platform 22 meters by 14 meters. Find the height of the platform. This platform is not built around the mouth of the well. It's a platform. It's not an embankment. Embankment is a protection that's built around the mouth of the well. Platform is somewhere else. They're making the platform. So for the well, so the two things here are the well, like in the earlier question, the two things were the well, the cylindrical well and the embankment, which is a cylindrical shell. Well, which is a cylinder, and well, which is a cylinder. You can see it here. Maybe you can write well, which is a cylinder. Well, which is a cylinder, and you have the embankment, which is a cylindrical shell. One second. Yeah. And here the two things are, again, well, which is cylindrical, and the platform. What's the shape? How does the platform look like? The platform has length, breadth, and you'll have to find the height. So the platform is a
Cuboid.
cuboid. The cuboidal platform. It's a cuboidal platform. Because we're given the length of the platform, breadth of the platform, and we have to find the height of the platform. So the cuboidal platform and a cylindrical well. Okay, so for a well, we need the radius, we need the height, and both given to us 7/2 or 3.5 meters, 20 meters deep. And for the platform, L is 22, B is 14, and H question mark. So see here, this is what we'll have to find. So what is the equation words here? Volume of the earth in the platform. Volume of the earth in the platform is equal to the volume of the earth removed from the well. Removed from the well. This is the equation in words. Volume of the earth in the platform is equal to the volume of the earth removed from the well. All the earth that is removed from the well is now, in the platform. So how do you find the volume of earth in the platform? Or the volume of the platform, cuboidal, LBH, is equal to volume of the earth removed is the volume of the cylinder, pi r square h. So substitute the values in this and find the value of h. Yes, children, please write down the answer. Any questions, children? So the height of the platform is 2.5 meters. Word problems, you must always leave your answer in a sentence. Don't leave it like the way you saw it earlier on the slide. Never leave a word problem, the answer to a word problem like that. H is equal to 2.5 meters. Don't leave it there. So please leave your answer as a sentence. Therefore, the height, what was asked, the height of the platform. Therefore, the height of the platform is equal to 2.5 meters. Done, children? All right. Yeah, this you can help yourself. Write down the answer from the slide. Read the question, go through the answer. Complete this now. So since 3 spheres are melted to form one single solid sphere, the equation is the volume of the big sphere will be equal to the sum of the volumes of the 3 small spheres. All the 3 small spheres put together make the big sphere. So the volume of the big sphere is equal to the volume of the sum of the volumes of the 3 small spheres. So you can see the difference there, R1, R2, R3. To represent the radii of the 3 small spheres, R1, R2, and R3. And the radius of the big sphere, capital R. The radius of the big sphere, capital R. Small spheres, R1, R2, R3. 4 by 3 pi is common and gets cancelled on both the sides. 4 by 3 pi is common and gets cancelled on both sides. 4 by 3 pi, 4 by 3 pi. So now substitute the values of R1, R2, and R3, 6, 8, and 10. And this works to 1728. R cubed is equal to 1728. So R is equal to the cube root of 1728, which is 12 centimeters. I hope all of you have completed writing this one. Yeah, this is also simple. Please complete this. Then we have the examples in this chapter. 1, 2, 3. Examples, I think. Yeah, and then we are done with the volumes and surface areas from the textbook. Oh, let me ask you to no, finish it, children. Complete this now in the class because you have the homework also to do. Sphere is melted and made into a cylinder. So volume of cylinder is equal to volume of sphere. One solid is melted and recast into another solid. So their volumes will be the same. Don't blindly write the answer. Read the question, go through the answer, and then write down. I'll give you that much time. There's no hurry. Is this over, children?
Yes, ma'am.
So see, how do you handle the decimal point? So if you want, you can write 4.2 as 42 by 10 and proceed. 42 by 10. So calculation, I'll leave it to you. 42, if you don't want the decimal point, you can write 4.2 as 42 by 10. In this case, you can simplify actually. So 3 ones are 3 ones are 3.4. 6 ones are 6 sevens are 42. 6 ones are 6 sevens are 42. So now 4 into 1.4 into 0.7 into 0.7 will give you 2.744. We'll do this and wind up the session for today, children. A hemispherical tank full of water. A hemispherical, not a spherical, hemispherical tank. What is the formula to find the volume of a hemisphere?
2 by 3 pi r cube.
2 by 3 pi r cube. Good, Arnav, thank you. A hemispherical tank full of water is emptied by a pipe at the rate of 3.4 by 7 liters per second. So the pipe, which see normally tanks have a pipe at their, at the bottom. At the bottom, there is one pipe at the top of the tank, which is the filling pipe, and one emptying pipe at the bottom of the tank. So this emptying pipe can empty the tank at the rate of 3.4 by 7 liters per second. So a little more than 3 liters of water will come out in 1 second. 1 second, if the pipe is open, more than 3 liters of water will come out of the tank. How much time will it take to empty half the tank if it is 3 meters in diameter? See, so the question is simple, like, if for one notebook you have to spend 50 rupees. For 10 such notebooks, how much will you spend? 15 to 10, 500 rupees. So similar, it's a question like that. The pipe can empty at the rate of 3.4 by 7 liters for 1 second. 1 second, 3.4 by 7 liters. So this volume of the water which is in the tank in how many seconds? And it's not the full tank also, half the volume of the tank. So see here, these are the steps. See, the first the question has to be understood. They have given you the speed of the emptying pipe. The speed of the emptying pipe. 1 second if the pipe is open, more than 3 liters of water, 3.4 by 7 liters of water will come out of the tank. Now this hemispherical tank is half full. It's not completely filled with water. Okay, how much time will it take to empty half the tank? Okay, maybe it's completely filled with water, but they just want to empty half the tank, meaning half the volume of the tank. They want to empty only half the volume of the tank. How long will that take? That's always the question. 1 second if the pipe is open, 3.4 by 7 liters of water will come out. How long should it be kept open? So that half the volume of the water, in the tank comes out. That's the question. If half of the volume of the water in the tank has to flow out, then how long should the pipe be kept open? Is the question. So for step 1, find the volume of the hemispherical tank. Find the volume of the water in the hemispherical tank. So you will find the complete volume. Then divide by 2 because you want to empty only half the tank. So divide that volume by 2. The speed is given as so many liters per second. So convert that volume which you found to liters. Find the volume of the tank, then divide by 2 to get half the volume of the tank. That water only has to be emptied. Convert that answer which you got now will be in meter cube because the radius is in meter, 3 meters in diameter. So the volume which you get will be in meter cube. The radius is 3 by 2 meters. So the volume of the water in the tank, half the volume of the water in the tank, you will get in meter cube. Convert that to liters. Convert that to liters. So now you have liters with you. So supposing it is given, it empties 3 liters in 1 second. And supposing half the volume of the tank, half the volume of the tank, supposing, you know, it's like say 90 liters. Half the volume of the tank. We converted it to liters, right? It was in meter cube. We converted that to liters. So how will you find 3 liters in 1 second? 90 liters in how many seconds? So 3 liters 1 second, 6 liters 2 seconds, 9 liters 3 seconds, 12 liters 4 seconds, 15 liters 5 seconds, 90 liters 30 seconds. In 30 seconds, 90 liters of water will come out. So you can use a proportion also if you're not sure. So you can say 3 liters is to 1 second is as to 90 liters is to how many seconds? X seconds. That's all, children. So take a screenshot. You can write this later. Please listen again. Please listen. Find the volume of the hemispherical tank. 2 by 3 pi r cube. 2 by 3 pi r cubed. 3 by 2 the whole cube. The diameter, so radius is 3 by 2. So you will get the volume in meter cube. Find half that volume. Half the volume of the tank will be half of 99 by 14, which is 99 by 28. Half of 98 by 4. Half of 99 by 14, which is 99 by 28 meter cube. Convert this meter cube to liters. If you don't remember, this is the conversion. 1000 liters is 1 meter cube. 1000 liters is 1 meter cube. See, you can always use the proportion again if you don't know, you know, if it is in the exam, if you're like, you're nervous, you don't know if you have to divide or multiply, you can use the proportion. 1000 liters is 1 meter cube. Is as to how many liters is 99 by 28 meter cube. We all know product of extremes is equal to product of means. We all know that. 1000 liters is to 1 meter cubed is as to how many liters? X liters is to 99 by 28 meter cubed. Keep that order correctly. Liter, meter cube, liter, meter cube, or meter cube, liter, meter cube, liter. So you can see product of extremes. You'll have to multiply 99 by 28 and 1000 is equal to product of means. X into 1 is X. So you'll have to multiply by 1000 to convert meter cube to liters. 1 meter cube is 1000 liters, children. So we converted. One meter cube is 1000 liters. So I said you can use this proportion. You can write it like this also. See it? 1 meter cube is to 1000 liters is as to 99 by 28 meter cube is to X liters. X liters. Okay. So you found you first worked the capacity of the tank, and then you found half the volume or half the capacity of the tank, so many liters. That's all. So now 3 4 by 7 is nothing but 25 by 7 liters. 25 by 7 liters. There's nothing but 25 by 7 liters. So much water comes out in 1 second. So much water will be emptied in T seconds. 25 by 7 liters is emptied in 1 second. So 99,000 by 28 liters will be emptied in T seconds. So I've just used the proportion there. I've used the proportion. See here, 25 by 7 liters in 1 second. So many liters in how many seconds? So product of extremes, 25 by 7 into T is equal to product of means. Work that and find the value of T. You get 990 seconds. 990 seconds, which is nothing but 16.5 minutes, or 16 minutes and 30 seconds. You should divide by 60 to find that. How do you do that? You should divide by 60. Divide by 60, 990. 990 by 60. 990 by 60. 33 by 2. 33 by 2 or 16.5 minutes, which is nothing but 16 minutes and 30 seconds. Take a screenshot, children. I'll clear the slide. Please take a screenshot and complete this answer. Lower your hands and raise your hands again, children. First, lower your hands, class. Class, lower your hands. Priyadarshini, are you there?
Ma'am, yes, ma'am. I raised again, ma'am.
Now again, class, use the emoji, raise your hand. Priyadarshini, Shivani, Priya, Tirunesh, Muttuvel, Shriya, Srinivasan, Arnav, Lakshita, Nivedita, Hariharan, and Sudarshan. Very good. Very good, children. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you.
Thank you, children. Good night.